Okay, we know about EULER. In our previous lecture, we had discussed about EULER trapezoidal predictor corrector method to solve first order differential equation. Similarly, we can solve first order differential equation by using EULER trapezoidal and then applying midpoint formula. So, what is difference between these two formulas and what is midpoint formula? An integration technique with the same order of conversion and Euler trapezoidal predictor corrector method is same. So what is midpoint formula and how it we can apply it to solve first order differential equation? So if we solve first order differential equation, y dash or can be written as dy over dx is equal to f of x y. We integrate here. The difference is on interval of integration, so we integrate the interval. Here is the interval from xn minus 1 to xn plus 1. So clearly if we note the difference here, xn minus 1, so next term will be xn, next term will be xn plus 1. So here difference is h, here difference is h, so total difference will be 2h. So this is difference between this formula and our previous formula. We can take xn to xn plus 1, and here in Euler trapezoidal predictor corrector method, h is equal to step size which is from xn to xn plus 1. Here there is difference xn minus 1 to xn plus 1. So further we can take it as this is interval of, if I take width, so width is 2h. So if I take diagram, this is y-axis, this is x-axis. If I take a curve, so here this will be xn and this point will be xn plus 1. So this will be xn minus 1. So this point will be x, midpoint of these 2 points will be xn. So this is x. If we take it as here, this is xn midpoint, so this is h and this distance will also be h. So h plus h, total distance will be 2h. So taking the integration, so we can write it as yn plus 1 minus, simply this is integration from xn minus 1 to xn plus 1 y dash of x y dash dx. This will be equal to integration xn minus 1 to xn plus 1, and y dash of x will be equal to f of x and y. Applying integration and solving after simplification, this will be equal to y of xn plus 1 minus upper limit minus lower limit xn minus 1 will be equal to integration from xn minus 1 to xn plus 1, and this will be f of x y, and this will be dx. So this can also be written as y of xn plus 1. This minus expression will be is equal to y of n minus 1 plus integration from xn minus 1 to xn plus 1 f of x y dx. Similarly we can write this expression as y of xn plus 1 is equal to y of n minus 1 plus, after simplification, this will be equal to 2h, and this will become f of order differential equation. Here if we take n is equal to 1, so this will be equal to y of 2 is equal to y of 0 plus 2h f of x1 and y1. So this is our midpoint formula. So here is example related to midpoint formula. Solve differential equation y prime is equal to minus y square 1 plus x, y of 0 is equal to 1 and h is equal to 0.2 and x is equal to 0.2. Find y1 from Euler predictor corrector method and apply midpoint formula to find y2. Simply, if I form the table, this will be x and this will be y. So this is x0, this is y0. So at x0 y is equal to 1. Similarly at x is equal to 1, and this will be y1, this will be x2, this will be y2. So first point is 0.2 and this is 0.4. so we had to form, we know that the Euler predictor formula is y of n plus 1, p is equal to y of n plus h f of x n, and this is y n. So here this is equation number 1. If we take n is equal to 0, so this will become y of 1, p is equal to y of 0 plus 0.2 f of x 0 and y of 0. So this will become y of 0 is equal to 1 plus 0.2, and this will be minus y1 will be equal to 1 square over 1 plus x 0 is equal to 0. So this will be equal to 0.8. So y1p will be equal to 0.8. So for correction, we will write it as, for correction we will put, for first correction m will be equal to 0 and n will be equal to 0. So this will be equal to, if we apply Euler trapezoidal predictor corrector method, so which is equal to y of n plus 1 c, this will be equal to m plus 1 is equal to y of n plus h over 2, and this is equal to y n dash plus y of n plus 1 p dash. So for m is equal to 0 and n is equal to 0, this will be equal to 1 c1 will be equal to y of 0 plus 0.2 over 2 y, this will be y 0 of dash plus y1 of p dash. So this will be equal to c1 y0 is equal to 1 plus 0.2 over 2, y0 dash will be equal to minus 1 square over 1 plus 0, and plus this will be equal to minus 1 y1 of p dash will be equal to, we will take this 0.8, so this will be 0.8 square 1 plus this will be x1, so x1 is equal to 0.2. so after putting the values, this will be equal to uh, 0.84667. So this is equal to y1 of c prime. Similarly, for second correction, m will be equal to 1 and n will be equal to 0. So this will become y of 1 c2 will be equal to y of 0 plus h over 2 y0 of dash plus y1 of c. This will be equal to 1. This will be equal to 1 plus 0.2 over 2. This will be minus 1 square over 1 plus 0 minus this will be equal to 0.84667 square over 1 plus 0.2. So after simplification this will be equal to 0.8402296. This value is equal to y1 of c. Second correction. Similarly, if I apply here third correction, so for third correction m will be equal to 2 and n will be equal to 0 in equation number say 2. So this will be equal to y1 of c3 will be equal to y0 plus h over 2 y0 prime plus y1 c2 will be equal to 1 plus 0.2 over 2 minus 1 square 1 plus 0 minus 0. Now we will use this value y1 c 2. So this will be equal to 8402296 over 1 plus 0.2. So this will be equal to 0.841037004. This is equal to y1c3. So after this was first correction, this is second, and this is third correction. So we can say first, second, third or fourth correction. How many corrections we are applying, this will be our correct root. So if I take another correction, fourth correction, m will be equal to 3, n is equal to 0. So this will be equal to, in equation number 2, so this will be equal to y1 of c4 is equal to y0 plus h over 2. This will be equal to y0 prime plus y1 c3. This will be equal to 1 plus 0.2 over 2 minus 1 square 1 plus 0 minus, here we will take value of y1 c cube. So this will be equal to 402 sorry, this will be equal to 0.841037004 square over 1 plus 0.2. So after simplification this will be equal to 0.841037004. So these two values are repeated, so we will take y1 c4. Here we will take this value in this point. So to find y2 by midpoint formula, so we know that midpoint formula is y of n plus 1 is equal to y of n minus 1 plus 2h f of x n y n. So here if we take, this is called midpoint formula, we want to find y2, so we will take n is equal to 1 in equation number 3. So this will be equal to y of 2 is equal to y of 0 plus 2h f of x1 and y1. So this will be equal to y0 is equal to 1 plus 2h is equal to 0.2. So this will be equal to minus y1 c4 correction 1 plus x. So this will be equal to, after putting the value, this will be equal to 1 plus 0.4, and this will be equal to minus 0.7073365744 over, this will be equal to 1 plus 0.2. Taking care of this expression will be equal to 0.70733657744. So after calculation and simplification, this will be equal to y2 will be equal to 0.7642 1 1 4 2. So this is value of y2 by applying midpoint formula. So here in this question we had applied trapezoidal predictor corrector method, and also another method which is midpoint formula to find the value of y2.